So last week we started playing around with the graphs of logarithms, and today we are going to start exploring how these can shift based on the structure of equations. So on your paper right here, I have given you a graph of the basic logarithm, which is just log base 10 of x, and we are going to shift that using this formula here. So if you can see here in our table, we have 2 plus log of x, and we are going to graph that alongside our first logarithm here. So we'll do this in blue on the screen here. And this is going to be as simple as plugging into our calculator 2 plus log of 0.1 for the first value. Because this is a base 10 logarithm, so we don't need to use the change of base formula. We don't need to use anything special to get it in there. So if I plug in 2 plus log of 1, we get 1 as our answer. So that's going in that first column there. We'll keep going through that table. 2 plus log of 0.5. This one will give us 1.70. We'll keep going. 2 plus log of 1 gives us 2. 2 plus log of 5 gives us 2.70. 2 plus log of 10 gives us 3. And 2 plus log of 16 will give us 3.20. So we can graph these points now with our x being our over, our y being our up. And I want us to look for the shift that's happening in that graph. So if we go over 0.1, it's barely off of our x-axis and we're at 1. So basically we can put a line at roughly there for our first dot. Then we go to 0.5, so halfway over, we're up 1.7, approximately there on our graph. Over 1, up 2. Then we're going to jump all the way over to 5 and go up to 2.7. Can go over 10, up 3. And we can go over to 16, up 3.7. And with that, we can now draw a nice little line here, connecting all of our dots. And we can see here on your notes, you're going to be asked, hey, what happens in our equation here? And we can see that from this little add to our logarithm, this 2 plus out in front, it has shifted our entire graph up 2 spaces. We've shifted up 2 spaces. Now, you're going to kind of write that observation on your note sheet, and you are going to repeat it for the next Explore problem 2, before you get into our notes. Now, before you do the notes, I do want to point out there is a Desmos tool you can hit on Google Classroom, or you can get from this QR code that brings you to this link here. And what it does is it allows us to we have our original log base 10 graph in red. And we also have this blue graph that we can play around with what this value is and check out how much it shifts. So as we go into our work today, we can start to play around with that a little bit, or maybe we can add some horizontal shifts as well and support our practice just as a comparison purpose and to help us visualize these shifts as they go. So back to the notes, let me get to where I'm at. So we're in the vertical shifts of logarithm sections. Let's get down this formula. Let's get down this brief description. And what you should have seen from your Explore activity is that if we get a number out in front, this K number out in front here, that is going to shift our graph vertically. So if the K is positive, it shifts it up. If it's negative, it shifts it down. If we look at example 1, 4 plus log of x, we have that K value of 4. So that is going to be a positive 4. It's going to shift up 4 spots. And if we look at our Desmos tool and plug that equation in, so over here we're going to go We're going to delete that 2. We're going to go 4. We can see, hey, my graph shifts up 1, 2, 3, 4 spots. Similarly, if we look at the example 2, we have -3 as our k value, so that's going to go down 3. If we look at our Desmos graph and plug that formula in, so change that 4 to a -3, I'll slide my thing down and we can kind of count, yeah, we shift down 1, 2, 3 spots. Okay, similarly, and what we saw in Explore Problem 2, we can have a horizontal shift. And this is going to happen when our number is inside of our parentheses, inside of our logarithm with the x. Now this one goes a little funky. If we have a positive value, it shifts left, positive shifts left, and negative shifts right. So this is also going to shift our domain and our x-intercept as well. Let's kind of talk through how this works. So in example 3, log of x plus 4. We should know just from this structure that, all right, we are going to go left 4. Let's look and see how this looks on our graph, though. So we'll kind of delete that k value that was out in front, and we're going to go plus 4. And let's reacquaint our zoom here. So if we look here, our red graph, our original graph, it had a domain from 0 all the way to positive infinity, right? It started at 0, went to infinity. Now this graph has shifted to the left 4 spots, so that boundary is now at -4. So if we want to write our domain in here, we would have a domain, I can write it DOM, of -4 is less than x is less than infinity. Okay, but we also want to find that x-intercept, see how that shifts. If I go back to my Desmos graph, our original x-intercept was at 1, and so that's also going to shift over left 4 spots. We can either count that, 1, 2, 3, 4, or we can do 1 minus 4 to give us -3. So our x-intercept would be -3 in that case. Okay, let's try this one more time with example 4. We can tell from our formula here, f of x equals log of x minus 5, that we have a shift to the right because it's a negative. We're going to shift right. Sorry about that. I must have hit something weird. All right, we're back here. We're going to shift to the right 5 spots. But we also want to find that domain, find that x-intercept. I'd encourage you to use Desmos for this. If we look over at Desmos and retype in our formula, so x minus 5 now, let's recenter our graph. All right, it looks like it shifts over 5, which confirmed kind of that prediction we made from the formula. It's also going to shift that domain over 5. So instead of being from 0 to infinity, we're going from 5 to infinity. So 5 is our left bound. It's less than x is less than infinity. And if we look at our x-intercept, it looks like it shifted over to 6, which is 5 more than 1. We can think of that 1 plus 5 there, or just pull it from our graph. Our x-intercept would be 6.